This is Team Threat Hunters and we are going to demonstrate how Eternal Blue actually works. So this attack simulation is divided into 5 parts. First of all, we'll scan for vulnerability. We'll get the target and see if it's vulnerable or not, and then we'll exploit it using Metasploit. Once the exploitation is done, we'll get a root shell, and with the root shell we can do all sorts of things. We'll upload a file which will be WannaCry payload, and then we'll execute it, eventually just encrypting all the files from the victim. And then we'll talk about mitigation techniques. So this is going to be our victim, IP address of 10.0.7.8, and this is our attacker 10.0.7.5. So first of all, as you can see over here, we are going to scan for vulnerability, and I've already done this scan, so I'll just show it right away. This is the basic host scan to check the available host on the network, and over here you can see it is up. And then we just check all the ports for that particular host, and we get all the open ports here. From this, these are two commonly used ports for the SMB service. SMB service is the one that's mainly responsible for this whole exploit. So now we'll just directly search for this script, and as you can see over here, it's vulnerable to this code execution vulnerability, so that it's having high risk. So basically this port 445 is vulnerable to Eternal Blue exploit. So now we see that the host is vulnerable. We'll just exploit the target. So we'll exploit massive console test queue for the silent mode. So now it's up and running. We will use exploit, just search Eternal Blue. Yeah, so this is the module we are going to use. Is exploit Windows SMB MS70210 Eternal Blue. So MS17 is basically the Eternal Blue was come into picture in 2017, so that's why it's MS17. SMB is the vulnerability that we are trying to exploit. SMB is vulnerable, and this is the Windows machine. Windows, this vulnerability is only available only for the Windows. Now we'll just set the payload up. We'll do set our host 10.0.7.8, set our port, which is 445 here, set L host for the local host, which is local IP 7.5. Yeah, set L host, and set L port, which is any port number works, any user defined port. Now we will set a payload according to our needs. It's a Windows system, so we'll just do Windows x64 payload, reverse TCP payload, and then as you can see over here, it's all good. There's nothing wrong over here. There are two files. That one is there. This is also an important file. Don't tell anyone this key to unlock. It's basically just like a secret file, and this is the password file. Just for the demonstration that what will actually happen once we exploit this vulnerability. So first of all, we will turn on the Wiresharks for better capture to see what things are going on underneath this whole exploit. So now we'll do exploit, and yeah, here we go. So basically, as you can see over here, target is vulnerable, and then we are trying to connect with different SMB. And here you can see the override is completed successfully. So basically it's kind of like in buffer overflow, but it's a bit different here that I'll describe a bit later here. Okay, so while this thing is going on, I will just say what actually happens here. So basically we are trying to get a predictable buffer. So for that we just include all the random characters into the buffer, like all the A's or all the B's, and also at the same time we are freeing up some blocks of the memory, from the buffer. And in that particular memory area where we had just recently freed up, we will insert our payload, and then that payload will be basically an malicious SMB request, which is like you can say malform SMB request, and that request will corrupt the buffer and eventually will give us a shell. So it's like we will try to overflow an already existing area of memory which are storing the pointers. We'll overwrite it, and that point, the return address will point to our malicious payload. So here they are just trying out different combination and failing, at least for now. We'll soon get a shell here. So now you can see here we just got the session. We can do ready to get the current path of the file. So now we are into the target. We can do all sorts of things here. Okay, so what we are going to do now is, let me just switch it here a bit. So now we have exported the target. We got the root shell now. Now we'll just upload the file. So over here we have a file called WannaCry.exe. We'll upload it to the target, and then we'll execute it and just basically just like run the malware. So we do upload. This is the file where the file is located. Downloads WannaCry.exe, and we'll upload it to the current directory of the target. Yeah, so basically the file is now uploaded at system32 folder. If you go to the target and so now we go to the system32 folder. Here you can see that it's already been executed, it's already been uploaded. So now what we are going to do is we'll just execute it. Execute this file WannaCry.exe. This will start the job slowly, and you will see some crazy stuff now. You see this one, and slowly the ransomware will start to install. Right, as you can see, it's that popular ransomware demand page where they ask you to send the bitcoins. So just cancel it out and see your old files are still there. We have secrets, but there's one more called secrets.txt dot .wannacry. They added dot .wannacry after that. And if you go into text, nothing over here. See, it will keep on popping every now and then, but we are not going to mind it. So let me just try to open this. Oh, the secret file is now gone. The only thing we have over here is just ending with WannaCry. We'll just try to open what actually happens. So they open it with a list of installed program and with a notepad. You see, it's all gibberish and unreadable. So basically, they just encrypted the file, and we cannot get it back unless we pay for it. So there's also security, as you can see. It's been encrypted now. So now this thing is completely useless to us. We either have to pay the group who's asking for ransom or just say goodbye to all these files. And that's why backup is important. If we had any backup, we could have just ignored this and restore the backup right away. So you can see over here. So WannaCry is not our main target. We just wanted to demonstrate how we can exploit the Eternal Blue and spread WannaCry to any machine on the local network. Just like that, we can even spread it to the other machines from the network. So that was the payload part. Uploaded the file, and now we will discuss the mitigation techniques. So first of all, to discuss this, we need to get back to our old system. Restore the snapshot. So while this is going on, we will talk briefly about what we can do about this. So basically, it was a problem with SMB v1. So our first goal will be just to turn it off. Turn it off the v1, and we are good to go. Another thing we can do here is just you can say upgrade your Windows to the latest version. In the past, when this thing was exploited, when Eternal Blue was exploited, they just released a new patch right away. They were pretty quick with the update, and that's why the damage was controlled just a bit, not that much. So once it was done, another thing we can do is, let me just show you. Yes, now we'll try to go back to it, reset time. Okay, so now it's all good. Back to what it was before. Alright, so now we can use the firewall as well. Windows firewall. We can add in one or outbound rules, specifically targeting to something like port 445, and that if there's any request incoming at 4445 from the outside, should get blocked. But there's one more thing we can do here is just add firewall. Yeah, so right now it's the firewall is turned off. So if you turn it on, by default firewall policy is just to close down all the unnecessary ports, and it will try to exploit it. As you can see, target is not vulnerable anymore because we have let me just do it again. So one more thing, while this is the packet capture of the this is a packet capture while MSF console was doing the attack. Let me just show you what kind of packets are being delivered here. So basically there are two types of payloads, packets being sent here. See, this these are all the garbage values just to fill up the buffers. And yeah, over here you can see these are all the, you can say, I don't know what it's called. These payloads are just to fill up the buffer, and there are also different kinds of payloads that are used to free up the buffer. And so if we just want to create buffer more predictable, we there are different kinds of buffer, like these are blocks. These blocks are filled up, and there are some blocks that are freed up in between there. Those blocks are holes in which we'll upload our payload and exploit the SMB. So this is yeah, I was about to show you the mitigation. So here you can see the exploit completed, but no system was created. It's also target of some vulnerable. Okay, so I'll try to do it again while the Wireshark is capturing the packet. Okay, so now see that transmission is not being completed here. See, so basically the target is not accepting the packet at all. The target is just like rejecting all the packets that are incoming at port 445. Because of that, our tag is not succeeding. See, it's not accepting the packets at all. Basically, that's the thing. See, the connection with this timed out. The connection is not. They're not even accepting the connection, and so that's why the tag fails if the firewall is on here. So those are the most commonly used techniques here for against this attack. Another one is using intrusion prevention system, IPS. We can do with IPS is we can create some few rules, and those rules will prevent the attack from happening. We'll just those rules won't be that different from the firewall rules that we can create here in this. Okay, so another thing we want to know, if we want to just take the attack, not want to delete anything else, just want to take the attack and leave it as it is. So we have Suricata rule. I created Suricata rule here. Let me just select it here from here and just set Suricata. Go to docs folder and cat test rules, not just test rules, and dot rules. And this is a rule specifically targeting the malicious packets that are being received at the client side. Yeah, so as you can see over here, so the different kind of packets are being sent. Yeah, so this we'll try to run Suricata now. Suricata. Yeah, so we try to use these rules and dot rules. This is our packet capture that we have just got. And this yeah, so we'll just ignore this thing. Now cat fast log. Yeah, over here you can see all sorts of different logs that have been created here. See, we got exploit possible X attempt stage, tree connect, and multiplex ID. Over here you can see attempt detected, class effective, attempt detected, and yeah, so that was the tag, and yeah, that's pretty much it.